We should start now then. The Since these are all familiar faces, I just have to ask questions. Any questions particular about HDF or any of HDF software before I start talking? No? All right. So today I will talk about a Rust package that I learned about last Thursday. So it's very new. And so I said, well, my slot for this session, call the doctor session, is coming up. So I thought this is an interesting topic. Um, and obviously it was interesting from as a software, but also it was interesting to me because of this picture of this drawing of this dog. And I don't know if to any of you this looks familiar, but to me it was. And this dog comes from a very French comic book series that I liked when I was much younger, and that was like, oh, interesting. And it was the comic book series called Asterix and Obelix. This is the Gaelic villagers who were fighting Roman legions back in the ancient France. And Asterix had his trusty sidekick named Obelix, who, as a child, fell into a cauldron with magic potion that gave superpowers, and so he was forever so strong that he always carried a rock around him like this. And this Obelix had a dog, uh, and this dog was, I knew a name as Dogmatics here, but now, interesting thing, in French actually, his name was not Dogmatics; it was the original name, and I can find it here. If not, turns out that the name was essentially this Hidefix without H at the beginning. And so I said, so that's the connection. H probably stands for HDF5, and Hidefix is the name of this dog, which I think something in French means, yes, see, there you go, Hidefix, which means a fixed idea, meaning an obsession. So the name of this Rust package, therefore, can be, probably translated to mean HDF5 obsession, which I thought, all right, then. When you have that and you see this dog from my famous comic book series, I think, it qualifies to be featured in my talk. And so, coming back to software, as I said, this is a Rust package, but like many things these days, and recently, it seems that the Rust packages have a very easy route into a Python world. And there's very good packages written in Rust are now starting to appear in the Python ecosystem. One is Polar S, which is essentially a tabular data package fashioned like the Python's own pandas. Also, there is one linter and code formatter called Ruf, also written in Rust. And there is also, I'm aware of as if Python doesn't need yet another package manager. There is, I think, one called UV, like ultraviolet, also written in Rust. And all of these packages basically claim to be very, very fast because they're written in Rust. And so this one, I don't know how to pronounce it. I would say Hidefix as far as the English language goes. Um, Also has its own Python bindings, and therefore, because it has its own Python bindings, it immediately was declared as, actually not declared, but has an API or interface into Xarray. So it can serve as a backend engine for Xarray. And Xarray is now extremely popular Python data analysis package. Its roots and origins are in pandas, but they extended that kind of functionality and philosophy to multidimensional data. And so I have not been able to try that yet. As I said, I learned about this last Thursday, but looks very interesting, again, because of all these connections. At the core of Hidefix is the approach that they're trying to solve this problem of faster or more performant reading of HDF5 or netCDF4 files. This particular, their current capability is only for local files. In other words, files in a file system rather than some kind of a remote data access, like Cloud Object Store or maybe some kind of a data service API. But as far as I can tell, nothing really prevents them to extend this approach to, let's say, S3, because Hidefix actually uses the Rust binding to HDF5 library. Therefore, there is a pathway there that they could at least use the native ROS3 read-only S3 virtual file driver that the library has. And their approach basically is to use the HDF5 library to open the file and extract all the information, what's in the file, meaning chunk locations and filter information and all that. And at that point, when they collect all that information, they go after those bits and pieces in an HDF5 file concurrently, asynchronously, in any way, using purely Rust programming language capabilities and its own packages, and treating that HDF5 file like an ordinary binary file. At that point, they don't need the HDF5 library anymore. And so they claim they're able to achieve quite good performance. And I will share some other screen now where I try to do something and try it for myself. So what I did is, obviously I wanted to try it out, but because I'm I love Conda virtual environments, I said I'm going to try and have everything run in a Conda virtual environment. And so these commands that you can see up there are really what I needed to do in order to be able to install everything that Rust programming language needs, clone the Hidefix repository, and then build and test and even run some benchmarks that Hidefix comes with. And so here is the first, and again, what I use micro-mamba, but the same command, wherever you see micro-mamba, you can replace it with Mamba, or you can replace it with Conda. It's the same thing. And so the first line here basically creates this virtual environment, and I obviously named it Hidefix. And then I install Rust, and because there's a lot of these Rust crates or Rust other packages that this Hidefix package depends on, you need to have CMake and all the other. Essentially, you have to have a virtual environment that's able to compile and build from source. And once I didn't know about M4, turns out I really needed M4, so that first try failed. But then when I added M4, everything worked. And so after that happens, for example, I'm now in that virtual environment, and I can, for example, show you that what is the version of the Rust compiler, 181, and Cargo, which is its trustworthy package manager, and a lot of other things, is also 181. The Cargo is really, I think, one of the big reasons why Rust as a programming language is going to be very popular, because immediately brings this idea of templating when you want to create a new Rust package. Also package management, dependencies, all the other things that really help those who want to develop in Rust easily share, reuse, and bring other dependencies in their development environment. So after cloning Hidefix and building it, and I'm sure that I don't want to run build again because it took a couple of minutes because it pulled a lot of dependencies, among other things, brought HDF5 library, netCDF library, and all the other things. It took some time to build, so I don't want to try that again. But interesting thing about HDF5 library, they are using their own patch of HDF5 library because the person who made, or the community that develops Rust bindings for the HDF5 library, they still don't have interface for a faster HDF5 library function to iterate through chunks. And they knew about that, and they brought their own patch into the Rust bindings to expose this new function, which is much faster when you want to detect chunk file locations, and they use that. So anyway, I thought, you know, for the purpose of this test, this one was the most interesting one. It basically compares concurrently, or basically compares four different ways in which they can access a local HDF5 file, which is a netCDF4 file, but that's, well, actually, no, it's HDF5 file. We can look at later. And actually, what does that while doing so? So as you can see, let me reduce the screen so I can. So there is a file that has a data set with a bunch of chunks, and each chunk is compressed with gzip and with shuffle filter. And so they're now testing various ways of accessing chunks of this data set that Hidefix supports. And the first one, cache concurrent reads. Cache means that Hidefix first opens the file, picks up what's everything in the file, chunks included, then closes the file, and then goes concurrently after these chunks. Cache sequential is, again, caches the chunk locations, but that sequentially goes after them. Direct sequential parallel, I have not been able to decipher what that exactly means. I was looking at the Rust code, but could not really. I know some Rust code, but not enough to be able to exactly say what's going on. The native concurrent reads and the native sequential. The native sequential is essentially using HDF5 library in the way it was meant currently to be used. And as you can see, cache concurrent and cache sequential are much noticeably faster than going through the HDF5 library right now. Native concurrent reads, again, I was not able to be 100% sure what it does to be able to tell yet. But as you can see, there is a range of results, and these ones, the most interesting ones. One thing that it can offer is that there are two command line tools that Hidefix provides. It's not HDF, I always forget. Yes. There are two of them, HFX IDX and HFX LST. HFX IDX basically tells you that actually it can be used to cache this chunk file location information and everything else what's in the file. And for example, if I have some file here, for example, actually not this one. Let me see, that's not, I think this is more. Yes, this is the one. And I want to store this information somewhere. I can do it here and we can look at it. This is the one, see, he done with indexing. And if I go and try to open this file, it's not text file, fortunately. Let me find where it is. Oh, it's not here. 1 second. It's a binary file with I could see some text and everything here, but obviously it's not text file. So it uses some specific format to itself, probably something from Rust, I would assume. But anyway, so he put this information here. so that next time they don't need to repeat this caching indexing operation again. As far as the files and how these concurrency benchmark tests look like, here is the Rust source code. So, for example, here's the file that they use: chunked, shuffled, zip, 2D, HDF5, and there's a data set in it with, I would say, 4 chunks or something. I think I can check that, and then various ways how it goes after reading them, and then obviously benchmarking these events. One interesting thing, of course, if you want to see what is this file, we can actually do it because they keep these files in the, oh, it's not here. Yes, of course, it's test in the repository. And for example, this is this file that they use. So if I click here, oops, sorry, wrong one. This is the one. I can pick up the link, its link in this repository, and then I can use my HDF5 web application that we have, which is a HDF5 file viewer, and I can drop this link here, and it can open that file for me, and I can look and see what's in this file. And for example, you see there's 2 filters, deflate and shuffle, and the shape is 10,000 by 100, and there are 100 by 10 chunk shapes, so there are more chunks than I thought. And so we can do even this way, in a very light and convenient way. We can look into this file and see what's going on. So that's the sort of the interesting thing about this Hidefix. What I think is a good approach here is that they're actually using HDF5 library to read the file content and get the chunk locations. I'm aware of one NASA software called H5 Coro, which was basically developed with the same need to sort of speed up reading of access to HDF5 files, but this time in S3. But that H5 Coro software, they actually started writing their own HDF5 file format reader. And somewhere along the line lost steam because there's so many variations of things and everything else, and they settled for a certain subset of interest to them. And I think that that's probably not the best use of their effort. I think that they should have used HDF5 library because it's already there. And then once they pick up all this information, they could go after bits and pieces from the file in the same way like this Hidefix Rust package does. Obviously, there is room for improvement, both for Hidefix and something like H5 Coro, and that is with cloud-optimized HDF5 files. I think in those cases, using HDF5 library to pick up the content of the file would be basically as fast as when that same file was in a file system. And that, I think, is everything I wanted to talk about. Obviously, there is the code and all the other things. All the software like this obviously has one challenge, I think, at least I would call it a challenge, and that is to support to some extent all the hyperslab operations or all the array slicing capabilities that HDF5 library comes with. So that's a big question, how much any of this software like this Hidefix will ever be able to do, but that's another story. But anyway, I think this is very cool. I think that's very nice. I think that it's good that there are other communities trying to go at HDF5 files from different angles. And I like that it's Rust, because I think Rust, and especially this combination between Rust and Python, are very interesting. because Python may never be as performant as Rust. But if there is enough developers willing to develop something in Rust, and connecting Python Rust packages from Python seems to be fairly straightforward, then there is a lot of potential there. And that's all I was planning to talk about. Any questions?
Alexander, you went over using your web viewer. I kind of lost the pathway there as you were describing that. Could you explain that again?
I only wanted to show that, for example, I was able to use this, how to call it? Well, this is someone else's software. It's called H5 Web. I think
Yes.
if we're going to be correct, yes. I just wanted to bring H5 Web as a convenient helper here, so I could show the content of the file without anyone having to download that file on their computer or anything else.
Oh,
Basically, that's all.
I see. Okay, you weren't using the output of Hidefix in conjunction with H5
No,
Web.
no,
Okay.
no,
I see. I got it.
no.
I got it. Thanks.
I just used H5 Web sort of to look what's in that file.
Yes, got it.
So I don't know, Alexander, if you're showing the screen that you think you're sharing.
I'm sorry. Yes, I'm not. You're correct. But anyway, I can probably stop sharing now, and probably should go back to the HDF. But yeah, that's the one. Yes. So yes, I only used it for that purpose. I was able to drop this here and basically just drop the URL of this thing, and then it just shows you what's in the file and what you can see and everything else.
It's a very easy URL to remember for that site.
Yes, it's myhdf5.hdfgroup.org, and the joys of web browsers.
Mm-hmm.
So yeah, any other question? All right then. If not, any question about HDF now? Has anyone thought about one, or wants to ask one, or bring up something else, some other HDF related topic?
Well, at the far end of that, question for Laurie about the videos from the hug getting posted. Did I miss an announcement, or are they up?
No, not yet. I'm so close to done. So close.
Okay.
I can, yeah, I'll send you an email, Quincy, because
Okay.
some of them are up privately if you need to see anything, but no, I haven't finished that work.
No rush, really. I just promised my group that I would send a trip report and was waiting for the videos. But it's okay if I wait another day or two or five. So
Yeah, no, yours is actually up, being worked on behind this window. So I can send you like a private link to share ahead of time.
no, they want to point at the mall, so I'll
Yeah.
wait. It's okay.
Okay, all right.
Thanks.
Okay then. If that's all, then I think we're gonna wrap up. Thanks for those outside of HDF Group for joining. I mean, it's August. It's a vacation month, so I understand it takes an effort, and so thank you for that. And I think next, I'm not sure who is next week, but someone interesting from HDF Group as well.
Yep,
So,
it'll be Scott next week.
sorry?
Scott will be up next week.
All right. Okay. Well, thanks everyone, and see you next month.
Okay, thanks. Bye-bye.
Bye bye.